So a ray of light through the focus will reflect and be parallel to the principal axis. So this is the image position. So the image height is here. Please note that this height hi is the same as from here to here. So if this is from here to here is hi, this will also be hi. Now let's label the parts of the diagram. A, O, this is B, okay. This is already F. So C, then E. Okay. Now we obtain similar triangles from what we have. From what we have, we could deduce that triangle AOF is similar to triangle FBE. We identify another similar triangle, and that is, oh, okay, E. So let's make this as G. This is G. Triangle CGF is similar to triangle FBP. So we've identified the similar triangles out of what we have. Now, when triangles are similar, the ratio of their sides are equal. So whatever, if you pick the ratio of the side of this to this, it must be equal. This and this must be equal. So let's consider AOF and FPE, the first one. So we are looking at the ratio of their sides. The side AO over the side of the other one, PE, must be equal to the side AF to FP. Okay, we can also consider this and that over this and that, but this side will give us nothing. Okay, because we've labeled from here to here to be the object distance U, from here to here to be the image distance V. So though this side over this side is true, but it won't give us anything. So we will ignore that part. We are not interested in that. Please, are you okay? Are you okay? Now, what is AO? AO is the object height HO. Okay, so HO over PE. PE is the image height HI. This must be equal to AF. What is AF? AF, we don't know. But one thing that we know is that AF plus FP is equal to the object distance. So U is equal to AF plus FP. We are looking for AF. So AF is equal to U minus FP. FP is the focal length, F. So minus F. So this becomes U minus F over F because FP is the focal length. Please, are we okay?
Yes, please.
Then you come and then look at the other pair of similar triangles. Okay, the other pair, which is CGF. Hello. Hello, I'm listening. Okay, so CJF, CJF, and FBP. So the ratio of their size as we did for the other pair. Okay, so CJ over BP must be equal to JF over FP. So okay, yeah, over here it can be this over this, or the choice it can be okay, both will give you the same results. All right. Now, what is CJ? CJ is the image height, HI, over BP is the object height, HO, is equal to JF. JF, we don't know, but here too, we know that JF is equal U, which is OB. U is equal to JF plus FP, making GF the subject. You have U minus FP is F. So you substitute it there. U minus F over F. So you have this as equation 1. You have this as equation 2. Okay. Now to equate both of them, the left hand side must be equal to the left hand side. But when we look at this is HO over HI. This is HI over HO. So you can pick any. It can be equation 1. Okay, if I want to make this to look like this, then HI on HO in equation 1 would be equal to F over U minus F. Okay. Then in the second equation, HI on HO is in itself U minus F over F. Please, are we fine? Are we fine?
Yes, please.
Then you equate.
Yes, please.
Okay, so if this and this down, then you can equate F over U minus F is equal to U minus F over F. Then you cross multiply. Okay, so U minus F times another U minus F. Oh, sorry. It's not U. This is V. This is not U. This is V. This is V in equation 2. So this is V. V minus F. Okay. So this time this is equal to F squared. Then you open the bracket. UV minus UF minus VF plus F squared is equal to F squared. This side goes to 0. Then you make UV the subject. UV will be equal to UF plus VF. When all these crosses are equal to sign. All right. Then divide through by UVF. Adwa, and here Adwa, when you divide through by UVF, that is when you can get the mirror equation. That's why we are dividing through by that. So the left hand side UV divided by UVF will be equal to UF divided by UVF plus VF divided by UVF. Okay, this, 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 and this. So we have the mirror equation now. 1 on F equal to 1 on V plus 1 on U. And this is our equation, mirror equation. So that's the proof of the mirror equation, how to derive it. Are we fine? And this equation applies to whether it is concave or convex. It will work. If you have any question, if you don't have any question, then let's look at um rotating a mirror. Rotating a mirror. Then we can start. We can begin with refraction of light. Do I clean the board? Hey, today you are quiet, so you don't even mind me. Do I clean the board?
Yes, please.
Oh, it's a pity. Rotation of the mirror. This is another area where questions are often asked. When the mirror is rotated through this. So if we have a mirror and there's a source of light, beaming a ray onto the mirror, and the source of light is fixed. In rotation of the mirror, we don't vary, we don't change the source of the light. Because, example, if the source is from the sun, the source of the ray is from the sun. You cannot go and change, after rotating, change the source of the light. The light will always be there, and then you do your rotation. So let's draw a normal to this mirror. The normal is N. There will be reflection, which will obey the law of reflection. Angle of incidence I would be equal to the angle of reflection R, which is also I. Instead of R, I'm using I because angle of incidence is equal to the angle of reflection. Okay. Now the mirror is rotated either clockwise or anti-clockwise. It is rotated through an angle theta. Now, once the mirror is rotated, the normal position will change. The normal position will change. Because the normal is always perpendicular to the mirror. So this will also give us a new normal N1 prime. There is a reflection as a result of the first position of the mirror. Please, are we okay? Are we okay?
Yes, please.
Now, when mirror is rotated, and it is rotated through an angle theta, the angle between the old normal when it wasn't rotated and the new normal when it is rotated, let me also make this as a broken line. So we have the new normal N1 and then the old normal N1. The angle between them is also equal to the angle of rotation, theta. So if this is theta, this will also be theta. And this is the reason. Look at this. There is a position of the mirror initially when it is not rotated. This is the normal, right? This is the normal to when it is not rotated. Now, when I rotate the mirror, look at how the normal would also change position. I'm rotating the mirror through an angle theta. So as you rotate the mirror, the normal also moves with it. Let me take it again. Let me get a pen to demonstrate the normal change. So this is the mirror's original position. This is the normal to it. Please, can you see?
Yes, Mr.
Yes, please.
Yeah, okay. So if I'm rotating the mirror through an angle theta, look at how the normal is also moving. So when you rotate it theta, the normal also moves through the same angle. Please, did you see that? So the angle between the old normal and then the new normal would also be equal to the angle of rotation of the mirror. So if you rotate it by theta, this will also be theta. Now, once rotated, it would give a new angle of reflection. So this is the reflected ray to the new position of the mirror. So R prime. So N and R prime are the original normal and reflection. The prime represents the new normal and then the reflection. Are we fine? All that we are interested in now. So to the new normal, this is the angle of incidence to the new normal. To the new normal, this is the angle of reflection. Now, we are so much interested in the angle between the two reflected rays. When before rotation and after rotation, the angle between the reflected rays, this is what we are looking for, this angle. Now, what do you think will be the value of the angle of incidence to the new normal, N prime? The incident ray and then the incident ray and then the new normal N prime. What will be the angle of incidence to it? Yes, can somebody help me? Assuming this is O, okay, we are looking for the angle. This is everyone said this is A. Angle A angle AO N prime. What will be this angle? Angle AO N prime. What will be the angle? And now the angle of incidence. Yes. I want somebody to look at it and help me. Yes. Nana Jemfua,
T
what to
It's I think to
okay.
be 2i.
Well, that is what she says. Yeah, it's somebody else.
theta plus the original angle of incidence.
So yes, Nana Jemfua, look at it. This is the whole angle from the incident ray to the new normal, to the old normal. This is I. The angle between the old normal and the new normal is theta. So if you are looking at AON prime, which is the angle of incidence to the new ray, it will be theta I plus theta. Okay. If AON prime is I plus theta, please what will be the angle O N prime O R prime? Yes. What will be this angle? Eliana, what will be the angle between N prime O R prime? Eliana. Eliana, are you there?
Yes, please.
What will be the angle N prime O R prime?
Um, I minus theta plus.
Eliana, look at it well. Adelaide, what will be the angle N prime O R prime? Adelaide, are you there? Oh, I think you are here.
Mr. Area, please, I had problems with the network, so I was not here from the start.
Okay, Hilda. What will be the angle N prime O R prime? The answer is so obvious. The answer really is so obvious. Matilda. Hey, people are quiet too. Now look at it. This is the angle of,
I
this is A O N prime, and it is the angle of incidence, okay, to the new normal. Now, what is the angle between the new normal N prime and then the new reflected ray R prime? What will that angle be?
plus theta.
Pardon?
I plus theta.
Exactly. That will also be I plus theta, because this is this, if this is the angle of incidence to the new normal, this will also be the angle of reflection to the new normal. And angle of incidence and angle of reflection have the same value, I plus theta. Okay, all right. So now we have that this whole angle would be I plus theta. We are looking for this angle. Angle O, angle R O R prime. We are looking for this small angle. But we know that angle N prime O R prime will be equal to this small angle N prime O R plus angle R O R prime. So if we are looking for this angle, then we will have to make this the subject. Angle R O R prime. I'll go over after doing it, so you follow. So when we make this as the subject, you have angle N prime O R prime minus N prime O R to give us this angle. Okay, now we have angle N prime O R prime, which is this. So I plus theta. All that we need is to determine angle N prime O R. Okay, and then subtract it from this to get what we are looking for. So think through, and then help me find angle N prime O R. This small angle. Help me find this small angle. So I'm giving you 2 minutes to think through, look at it carefully, and then come out with what you think. We are looking for this small angle to subtract it from I plus theta to get what we are looking for. 2 minutes, start work. Just look at it and think through. I'll come back to you. 1 minute more. Okay, I'm back. So, class, what did you get for this small angle n prime OR? What did you get for it? Yes. Let me have your views. Whatever you got for that. Nana Jemfua,
Mr. Edia, please, I think it's
I got I minus theta.
you got I minus theta. Who else? Let me see. Who else? If you got any other thing. Okay, so let's see.
Mr.
If yes. Oh, I'm
Mr.
listening.
Edia, please, it's okay. You can continue. Oh, please, can continue.
Okay, so let's look at something. When the mirror is not rotated, the angle of incidence is this, and the angle of reflection is this. So this is I, and from here to this point is also I. So the whole of this angle NOR is I. Okay, the rest of the angles are also within. So we know the angle NON prime to be theta, and we are looking for this. So it means that angle N prime OR must be equal to the bigger angle, which is I minus this angle theta. So she's right with what she said. Okay, so we put it at minus I minus theta. Okay, so we can find the angle of reflection between the reflected rays, which is angle ROR prime. So angle ROR prime becomes I plus theta minus I plus theta. This and this cancels out to 0. And so we have 2 theta. Meaning that the concept is that when you rotate a mirror, when mirror is rotated through an angle theta, the angle between the reflected rays is twice the angle of rotation, theta. When you rotate a mirror, the angle between the reflected rays The old one and the new one is always twice the angle of rotation. Meaning that if you rotate the mirror maybe through an angle 15 degrees, the angle between the reflected rays will be 2 times 15, 30. If you rotate the mirror through so and so angle, it is always twice the angle between the reflected rays. That is the concept and the rotation of a mirror. Any question?
Please, teacher.
Eliana,
Please, I still don't understand why n prime or r prime is equal to I plus T.
okay. Then I want us to go over it for the last time, okay? Class, is that okay?
Yes.
So let me clear everything. So we have a mirror. So this is when the mirror is not rotated. So this is the mirror. So once a source is being directed to it, we have source of light. Under this concept, we don't change the source. It is always fixed. So you can do your rotation, but the source is always what it is. So this is the reflected ray. If we draw a normal to it, the normal divides the angle between them into 2 equal parts. The normal is always perpendicular to the mirror. So this is N. So N for original, this is I. This is R for original A. This is I, and this is also I. Angle of incidence equals the angle of reflection. So now the mirror is rotated. This is clockwise rotation. It can be anti-clockwise rotation. The value will still be the same. Now, Nedubi, are you there? Edubia is gone. So the angle of rotation is theta. Now, once the mirror is rotated, it would give a new normal. The normal is always perpendicular to the surface. So there will be a new normal. Okay, this is N prime, perpendicular to the surface. But we just saw that when you rotate a mirror through an angle theta, the angle between